There are many types of IoT. We have these, but there are two main differences. Those use unlicensed spectrum and those that use licensed spectrum. We have the short range, which is a very high volume. They use Wi-Fi. We have something called Zigbee that's typically used for electrical switches, thermostats, etc. in homes. RFID that you can have on your mobile phone. Bluetooth is quite common. And you have the Zigbees once again for car keys. And these have a typical range of 10 centimeters to a couple of 100 meters. They can have they use unlicensed spectrum, 2.4 gigahertz. What can be mentioned about 2.4 gigahertz, it's very often a high interference there because there are so many Wi-Fi networks. If you check the Wi-Fi networks close to your home, if you live in a city, you see many of them. Peak data rate can be hundreds of megabit. It depends on which technology. Wi-Fi gives very high throughput. Typical use case is short ranges, smart home and factory. And module cost, there are so many different types of module because the technology here is also quite different. So let's go to something that looks more like the LTE-based, which is called Sigfox. This has quite good coverage. It can allow quite weak signals. It works in unlicensed spectrum in the 900 megahertz. There is some bandwidth available there. It's low throughput, 100 bit per second, and it's used for smart grid, smart city, and monitoring. Device cost is quite good, $4 in 2015 and $2.6 they expect in 2020. This is rolled out in France, I think Czech Republic, and maybe Spain, but not many countries. Then we have a system called LoRa, where you also have a forum, and this is also a low, quite good coverage. It's run in unlicensed spectrum, less than 500 kilohertz bandwidth, around 50 kilobit is a throughput. Used for smart grid, city monitoring, 4 to 2.6. All these, which are unlicensed, they are not 100% reliable because you don't have control of the spectrum that you use. You may suffer from interference. Unlike these IoT, 3GPP specified, we have within LTE, we have two main groups. We have something called LTM, which have some bandwidth of 1.4 megahertz and cover up to 1 megabit per second in release 13. This is also the same use cases and also for vehicle, and this is, so you have this bandwidth. It's usable for video surveillance. Device cost $5 in the beginning, and we expect it will go down to 3.3 approximately. Then we have the other one, narrowband IoT, which is very well suited for metering. This has a coverage of up to 15 kilometers now in the higher frequencies and 164 dB path loss, which means 20 dB more than standard LTE. This uses licensed spectrum, 200 kilohertz. We will see closer to have a closer look at the throughput. This is for smart grid metering, monitoring, and here we also see device cost will approach a couple of dollars. I will not go down to this one, but what I would like to mention with extended coverage GSM, that was also standardized in 2016. The interesting thing is that the standardization made changes to the GSM standard that was backward compatible 25-year spec. And that is also one main reason why one should go with the 3GPP standardized solution. It has been thought through by many people, operators, users, vendors, and even regulators are involved. And when all these people think together, you get good solutions. And they are also backwards compatible. A little bit on the throughput. In 3GPP was the first release we got LTE. The standard mobile was category 4, having support of 150 megabit per second in downlink and 50 megabit per second in the uplink. even that was what it could do in peak rate, and if it has the cell for its own, it could even sustain that capacity. Already then they defined a terminal that was well suited for IoT devices or IoT application, which had lower throughput. And both of them cover all bandwidths, and this one has reduced complexity. A standard mobile, LTE mobile, we say has 100% complexity as a reference. This stripped down version has 80%. If you then go to release 13, where we get the first IoT, then we had LTM, as mentioned, which is LTE for machine or enhanced machine type communication. This could have peak rate of up to 1 megabit per second uplink and downlink if you have full duplex. Sustained is around 890 kilobit per second in the downlink and 1 megabit per second in the uplink. If we go to a simpler version of it with half duplex, it has 300 kilobit per second in the downlink and 375 in the uplink. And this is to reduce complexity. When you have a duplex, you transmit in half of the time and you receive in the other half, or you can have a different ratio. So it can even have a lower power output to save battery. Here we see that the complexity has dropped to 20% of standard mobile. That is also the reason why the modem can have lower cost. Also, one thing that we can see here is that typically for standard mobiles, we prioritize the downlink. So the downlink has higher throughput than the uplink. And that's also our normal use case, that we download more data than we produce and send up. But for these devices, the uplink has the highest capacity. Because typically we would like to read out data. We don't need to send so much data to the device. Then we have a very interesting category, NB1, narrowband IoT. This has a peak rate of 170 kilobit per second in the downlink and 250 in the uplink. But what we usually calculate with, and that's the sustained throughput, is 26 kilobit in the downlink and 62 kilobit in the uplink. And this has half duplex. Then we can also make the device a little bit easier without filters. It has a bandwidth of 180 kilohertz. That means what we call one physical resource block in LTE. It can transmit with 20 or 23 dBm. The complexity is 15% of a standard LTE mobile. So then it becomes much easier, because we cannot spend so much size either, because it has to be small. It shall fit within small devices. We need a coverage enhancement of 15 to 20 dB. We need to cover places that are very difficult to cover, like basements, like metallic enclosures, cabinets, where we can have meters inside. One of the first things we can do is to steal some powers from neighboring resource block. If we have a 5 megahertz bandwidth transmitting at 40 watt, which can be quite common in LT450, each of these PRBs has 1.6 watt. If we steal each of them, we can add it to the one in the middle. So there we can boost the signal with up to 6 dB, which means more than doubling of the signal level. The other thing which gives quite a good coverage enhancement is to repeat messages that we transmit. That means we send a message and we send it once more and send it once more. The receiver will receive the same message many times, and it starts to decode the message. Some part of it it's able to decode, some is maybe buried in noise, and then it has to pick out the signal and decode. But when it get this repeated maybe 100 times, it will be able to decode it. At the end of each message, there is a checksum, so the receiver knows when the signal it has received is correct. So if the start of the message together with the checksum at the end correspond to each other, the message is correctly understood. So this one is the one that gives most signal, but of course, doing this also means that we deplete the battery in the device because it has to receive quite much data. And to avoid that we do this with all the devices, the network is divided into 3 groups of coverage levels, so that not all those that has a good coverage, they don't have to repeat so many times. It's only those that need to have this strong boost. So therefore that's divided in 3 groups. Another way to save energy is what we call enhanced discontinued reception, DRX. Actually, we only need to transmit a small amount of data when we have narrowband IoT. It's meant for small amount of data, like meters. And then we transmit, and then the device go and sleep. And we can sleep up to 2.91 hours. And then we have to wake up again and listen to if the network wants something from us. Or we want to send something. And in many cases, actually, the device only needs to send once a day, like a water meter, unless you want to survey and see if there is any leakage in your system. It's also important when you design your system that you don't ask many devices to transmit at the same time, because then they will queue up. And when they are waiting, they are also wasting battery. So typically, when you shall read out your devices, you take device number 1 here, and then it sleeps until here. Then you take device number 2 here, and then it sleeps to here. And so it goes. With this way, you can save a lot of energy, and your battery will last for 10 years or more. And standardization continues. 3GPP release 15, where we have narrowband IoT. We work further to reduce the power consumption and latency. Larger cell radius, at least 100 kilometer support. Up to now, narrowband IoT support 36 kilometer. That has to do with the structure of the control channels. Support in small cells, TDD-LT, and also some enhancement in access barring. That means that you can bar a device to access your network. And some standalone operations that you don't have to have it within your own bandwidth. When we look at the machine type communication or enhanced MTC, same with reduction of power consumption. We support higher velocity of the UE because we see also the car industry is interested in this. We have a download of software for cars using this technology, improved load control, and also support lower power classes. Even for machine type communication, you need to, some of video cameras need, for instance, to be supported by a low power device. Can be a small battery together with a solar panel. And also improve spectral efficiency. There is no specific position enhancement plan for IoT. Typically, IoT, we have been thinking of that as a static device. And where you need position, you typically use GPS instead of using the network and triangulation to calculate where the device is. Unlicensed IoT, there's no plan in 3GPP. They look at the license spectrum mainly. Though in the 5G new radio, they look at maybe unlicensed spectrum. The issue with unlicensed spectrum is that it can be either very much interference there, or you have no control, or it's a very high frequency, like 5 gigahertz. That is not so polluted, but the coverage is very limited. Let's take a look at some IoT use cases. Can be some examples, some for inspiration, etc. We have in Nokia, we have looked at 9 categories of use cases. We have public safety, digital health, mobility, we have industries, other smart cities, utilities, smart homes, retail services, and IT. In public safety can be surveillance, tracking, You have digital health, preventive health. You can have patient care. People can live much longer at home because you can be surveyed by your doctor from your home. You have connected roads, vehicles. You have connected trains and connected planes and ships. In industry, we have smart production, agriculture. We'll come back to some of them. Smart building, smart cities, traffic, parking. You have waste management and utilities and smart grid. Smart homes, you can have smart music video, smart lighting and temperature, retail services, smart payment stores, and an IT network. You typically have it for, can be surveillance of routers, switches, if you want to have something independent of your network even. So if your network should go down, you can still get access to a device out in the network from your mobile network instead. One use case is smart lighting, where you can use sensors with IoT and you can detect how strong is the street lighting. Typically, when it starts to get darker, you start with stronger lighting and then you can dim it when everything becomes weaker to save some energy. Even in some streets that there is no traffic, you can switch off the light until some traffic comes there. You have energy monitoring. You can also use the data from the lighting sensors to verify that the light bulbs are okay. If the light is becoming weaker, you should go out and exchange your light bulb because it approaches end of life. And if you can do that in a planned manner instead of doing it case by case, you can save quite much cost for having servicing people there. And smart parking management, where drivers can be led to the closest free parking space. They assume around that 30 to 40% of the traffic in cities today is people that look for a parking place. If they can be guided to a free parking place close to where they want to go, they can go directly there instead of searching and looking for the parking place. And this solution that they made can even be used for garage without public coverage. But of course, you can have a coverage inside here and you have an external antenna and you connect to the network and you get on your mobile or your navigation device where you can find a free parking slot. Then we have connected bus shelters. It's nothing as boring as waiting for the bus and you don't know when it arrives. Now we have these panels showing when the next buses are coming. The only thing you need to get out there is a power connection and you have the IoT device. You don't have to pull out a telecom cable. And you can also use this for other relevant traffic. If there is some problems with your bus, you can get some alternatives routes. You can have digital advertisement for tourists, and you can even use it for commercial advertisement. And this has been done in Auckland and Amsterdam and Paris. Also, if you look at the smart cities, we see an exponential growth of cities. In 2050, it is believed that more than 70% of the population on Earth will live in cities. And that put a very strong pressure on the cities. They must be safe, they must be smart to handle all the people moving into a small area, and it must be sustainable, it must be environmental friendly. To be able to handle all this growth, we need some digital support. And we will take a look at these further. One thing, it's quite tempting to just implement one system from the waste handling, one for lighting, for instance, one for video surveillance. All these systems, you can quickly get them up and running. Challenge is if you want to reuse some of the data from one system to another system. Therefore, we believe that the smart cities, they should have a fully integrated approach. They should connect all these devices together. Then you can reuse data, and like smart parking can be also useful for all the other here. You have a smart lighting. If there is an incident somewhere, maybe the ambulances need to have all lights on in that area. Video solution tells the waste management people which waste bins seems to be overfilled. Speaking about waste, we have a company called Enevo, and they have made a system where they have sensors in the waste bins so they can survey the filling rate. They have a management app, and on the truck driver, he or she sees which waste bins that start to be filled and get a recommended driving route. Because you shall not empty them too frequent, because then you waste energy by driving too empty. But you should also empty them before they start to be overfilled. Then else you will get a lot of waste around them. And we have a mobile app that the team that works on waste management can go in and set up. And they can also configure when to trigger emptying of the waste bin. Then we have these so-called multipurpose sensors, which can measure environment data, liquids, water, noise, light, parking. Agriculture can use it for detecting if it's dry, if it's wet, ambient control, radiation, etc. So these can be connected either via narrowband IoT directly. You can have a concentrator. Let's say you put them into an area in a city, or a farmer put them out on his farm. He can concentrate the data and then it's transmitted up. So this supports several technology like Sigfox, LoRa, narrowband IoT. Here is another one for agriculture. It's for plant protection, irrigation automation. When it's dry, you need to give water to the plants, and then you can start irrigation. You have insect monitoring, which is a challenge in many countries. Frost warning, which is a challenge in our area. Nutrient sensing. So this weather station will tell the farmers if it's danger of insects. Sometimes they need to they can protect them by putting some net, or worst case, they need to use some sprays to avoid insect. Here is also one for air quality monitoring, where you can have different sensors that senses nitrogen dioxide, NOxes, carbon monoxide, sulfur dioxide, ozone, and can be used, for instance, in cities where you have a lot of diesel traffic. You can survey and you can give a recommendation to the public. Or even in some areas where you have, let's say, you are a bus company having many diesel buses in a small area, you can survey that the air is okay for the people working there. Here is one for a company called Luminosity, where they have developed a smart light pole. You take away the standard lighting and you put on this one. Of course, the heart of it is a LED module that give you light. That's what you need. So it has 1 to 4 LED modules, dependent on the height, how much light you need. On top of that light, you can add a radar sensor, which can sense, for instance, traffic. You can have an air quality sensor. You have a modem that connects to your network. And you can even have processing power, where you can pre-process the data. You have enough energy here, no doubt about that. So you can do pre-processing of data. So the data that you have to send back can be reduced quite much. So you can use it, for instance, for smart parking. If there is a parking lot under this lamp, it can detect how many cars there are and which parking spots are available. You can use it for traffic metering. If this is along a road, you can measure the traffic by using the radar and find out whether it's a traffic jam or not. And you can also measure how much people that is walking there, the speed and direction of the people. And that might also, for some incidents, be important. If there has been let's say, a big sport event and many people are starting moving, it's important for the, let's say, the subway to pick up the people and have enough trains available. And it can also measure vibration, tilt, etc. Then you have a company called CE+ Rosenberger. They have a telemetric and tracking. You have container monitoring. One challenge with a company owning many containers is that they don't know where they are. They've been moving around. Having a GPS receiver together with an IoT device, you can find your containers at any time. Telematic for following up machinery. So that you install a tracking unit with a SIM card. And you can have also a machine-to-machine lock, including SIM card. For instance, you can have a lock on the container itself, so it can only be opened when you are connected remotely to authorized people, which means it's difficult to break in and you cannot force somebody to lock it up for you. And they have also a variety of sensors, and they offer a management tool to set up what you want these devices to do for you. Then you have a RACAP, remote monitoring and maintenance. Here you can see a windmill park. And one alternative is that you pull telecom cable to all of these windmills, which is can be kilometer of cable here, and you need to dig it down. Even though you have power cable in the ground here, it's much easier to have a mobile device per windmill, that you survey the quality of the power, is there too many harmonics on it, etc. You can survey the bearings if they start to wear. And here you can see also surveillance of power lines. Some devices for IoT services. We have meters for gas, not so common in our area, water, electrical power. For tracking, we have GPS tracker, we have SafeWatch, we have some key watcher and GPS tracker. Can be used for people, can be used for animals, can be used for cars and any other assets. You have monitoring, portable gas meter, car parking, environmental monitoring, construction monitoring, and traffic light monitoring. And also bicycle tracking. It's very popular in cities that the cities offer bicycles. And it can be difficult to get hold of where is the bicycle at any time. Or bicycles disappears and people use them, leave them, and they don't find them again. But having an IoT device on a bicycle together with GPS, then you can find it. Then you have some control. You have manhole sensors, that they are properly locked, shock sensors, water level is important, electrical power control, temperature sensors, and smart car parking. Also, one thing I would like to mention is you will probably need to develop some applications, even though there are already a lot of them available. There are many tools, many companies that make prototyping cards that they contain an IoT sensor and they contain IoT. So you can connect them, for instance, to a Raspberry module, to a PC, or to any other I/O device. They have several output, input, temperature sensor, input, output, etc. So you have Gemalto, Telit has a card, Mango has a card, you have u-blox, and Bosch has a general IoT device that you can program yourself. What about IoT and the future? What does the standardization say about the future mobile communication? They have divided it in 3 different use cases. This triangular is used very much for the 5G ecosystem. In one of the corners, you have enhanced mobile broadband, which means gigabytes in a second. For us working with IoT, that's normally of non-interest. We don't need gigabytes in seconds. We need a reliable communication. Not so much data, but it must be reliable. So therefore we have this massive machine type communication. Massive means that we can handle many, many devices at the same time. And you have also the other one, which is ultra reliable, low latency communications, where we think about self-driving car, we speak about remote surgery, any other things that needs very reliable communication. Interesting to see also the 450 megahertz is the first choice there. Gives a very reliable communication. You have very good control over the radio conditions. So, as a summary of this seminar, I would like to mention a few things. 450 megahertz ensures coverage that far exceeds other radio technologies or frequencies for mobile communication. Technology is standardized in 3GPP that ensures an ecosystem with many compatible devices. That's the good thing with standardization. You make the standard, it's open for everybody to make equipment. Running IoT over net once network ensures reliable communication over licensed spectrum and a protected environment. It gives security, integrity, and availability and reliability of your IoT data. Thank you.